Here we are again, Chapter 2 problems for Physics 110. Problem 4. The great galaxy in Andromeda has an angular diameter along its long axis of about 5 degrees. Its distance is about 2.2 million light years. What is its linear diameter? This is challenging in that we did not directly discuss how to do problems like this in class. But this is explained in the textbook, on page 45. It shows this situation when you have something like a galaxy that has some diameter, some distance from one end to the other. We call that distance L. If you're looking at that, there is some angular size, some angle through which one edge to the other. You'd have to sweep your arm through that angle to go from one end to the other. In the textbook, they use the Greek letter alpha to represent this angle. Why not just use the letter A for angle? That would have been less confusing. But alpha was used. The idea is that these two numbers are related by a third, which is the distance from where you're viewing this object to where the object is. We call that distance d. In the textbook, they work out the formula relating L and alpha and d, and this is the formula they got in the textbook. L is 2 times pi times d times alpha divided by 360 degrees. So if you know d and you know alpha, you can figure out the linear diameter of your object L. Well, that's the situation we're in here. We were given 2 times pi. We were given the distance, 2.2 million light years. That means 2.2 times a million. Light years, 2.2 million light years. And the angular diameter, the angular size was given as 5 degrees. That means the Andromeda galaxy in our night sky, if you have dark enough conditions, it's 10 times wider than the full moon is, really. Divided by 360 degrees. So the degrees units cancel out, but we still have our numbers there. If we do 2 times pi times 2.2 times a million times 5 divided by 360, we get 192,000. I may have rounded off, just kept the first 3 non-trivial digits, and we have light years. And that's our answer. The diameter of the Andromeda galaxy, 192,000 light years. It would take light 192,000 years to travel from one end of the galaxy to the other.